Hi, grade 11. So I'm just going to be going through the notes that Mr. Gomes put up. These are the official class notes. One from the first video that I put up is just some extra ones, simpler ones to work through. So this should be the second video that you watch. So your solution of triangles, remember, is working with non-right angle triangle focus mainly. And we're going to be learning 3 rules in this: the sine, cosine, and area rule. My first video just covered the sine rule, and then I will put up one for the cosine rule and the area rule. So just remember there's some triangle etiquette. So just if you're working with an angle, it's a capital. If you're working with the side that's across from it, it's a little letter. Right, so here's your sine rule again, using the knowledge from the previous video. And these again are the conditions that you would be able to work with when you want to use the sine rule. Because remember, later we're going to introduce the cosine and the area rule. And so you need to be able to differentiate when you can use each rule. So you'll probably come back to that more later on. All right, so here's an example. They've given you, this is from your textbook, page 163. So you've got triangle ABC, you've been given angle A, B, and you've been given a side. So now very key in this is the fact that you have one entire pair. And so your focus is going to be working out that side AC first, which is what they've asked you for. So I always like to go with what they've asked for first. So side AC over what's its opposite angle. It's sine 60 degrees, which is equal to then the complete side over its angle. Then we're going to rearrange just by multiplying that sine 60 across and then still dividing by the sine 50. So we get AC equal to 11,31 units. All right, so we got that 11,31 units. Now for side BC, you can't use Pythag. It's not a right angle triangle. So you also can't use your old style trig with opposite over hypotenuse. So this is needing the sine rule here. So in order to work out BC, I think it's supposed to be BA. Just watch here, BA, because we know what BC is. So this is 11,31. Got our angle, so we need to work out BA, the missing one. But do we have its opposite side? No, but we can work it out because we've got 2 angles in the triangle. So angle C must be 180 minus 50 minus 60 angles of a triangle. So that's 180 minus 110, which is 70 degrees. All right, so then now you actually have that third angle. You can work out the opposite side. So we're looking for BA over sine 70 is equal to, use your original given side and angle, sine 50. So BC, not BC, sorry, going back to that. BA is our missing one. That's highlighted, BA. All right, so BA is equal to 10 sine 70 divided by sine 50, which is equal then to 12,27 units. Okay, so now for example 2, let's see what they've given us. They've given us, there's our complete pair, angle opposite side, and they've given us another side. So the first thing we can do is calculate angle F. Now let's read the question. In triangle DEF, they've given you E, DF, DE. Calculate the size of angle D. So now angle D is here, but it has no opposite side. So if we work out F, we can use angles of a triangle then to look for angle D. So let's start with getting sine F. Put what you're going to solve top left-hand side. Its opposite side is 7. So I need now my angle at the top, sine 100 over 20. Take that across. So sine F is equal to 7 times sine 100 over 20. And so because it's an angle, you've got to say shift sign in your calculator of that fraction. And so you get your angle equal to 20,16 degrees. That's for F. So then angle D must be 180 minus the 100 minus the 20,16 20.16 because of angles of a triangle. So 180 minus 100 minus 20.16 gives us 59.84 degrees. All right, so there's your angle D that they asked you for. Okay, last example before your exercise. So in triangle KLM, you have K being an obtuse angle. So that's key. They've obviously given that for a reason. KL says it's 10 units on the picture. So let's just go with what the picture's saying. 15 units. LM is 25 and M is 30. All right, so when we're working with this, they're now asking us to find the angle K. We've got to pay attention to the information about K. So let's see where that gets us. All right, so then we're working with our complete side here, so we can work out K quite easily. So sine of K over 25 is equal to sine of 30 over 15. So sine of K is equal to sine 30 times 25 all over 15. So sine 30 times 25 divided by 15. And then shift sign of that answer in your calculator. And that gets us to 56.44 degrees. Now, this is something that's covered there's an additional video called the Ambiguous Case. This is an ambiguous case because diagrams can be drawn very differently. So in this case, I mean, we could have had K drawn very acutely where this could be definitely 56.44. That could still be 30. So the diagram can sometimes be misleading. That's why they had to tell us very specifically that it was obtuse. And so when they tell us that, we need to bring in the obtuse angle, which therefore means K is going to be 180 minus 56.44, which is equal to 123.56 degrees. All right, so this is called the ambiguous case. Please watch the video on the ambiguous case to get clarity on this. All right, so then you can do exercise 1, the entire exercise. It carries on the next slide, and then there's just some extra examples, worked out examples that you can have a look at. Just shows you some more processes. It also shows you another ambiguous case over here, right? So you can work through those ones. And then you have an additional set of notes on the sine rule, the proof of the sine rule, just how it works, and then another little exercise to work on as well. All right, so that's just the notes that Mr. Gomes put up yesterday.